Dear students, today we will see the dielectric concept, and this is also one of the major topic while solving the numericals or applications in the competitive exams as well as in board exams also. Here up to last lecture we have seen the applications of a parallel plate capacitor. If the mediums, it will be whether it is a completely filled or partially filled, how to calculate the capacitance of parallel plate capacitor we have seen. Now we'll discuss the concept dielectrics, or we can call it as dielectric material. Whether dielectric or dielectric material, both will be the same. So what is a dielectric material? Generally we'll see any material which do not possess free electrons, that material is said to be dielectrics. So here I will write the definition: dielectric, any material which do not possess free electrons, or we can write any material or any substance which possess very less number of electrons which constitute electric current. Are known as dielectric materials. So this is a simple definition of dielectric material. Here we should remember any material which do not possess free electrons, or the same material it may have very less number of free electrons. So that material, it is said to be dielectric or dielectric material. So here we know the atom consists of a nucleus, and the nucleus which is located at the center. And what is the charge inside the nucleus? That is generally positive charge. Here if you see, and the around the nucleus free electrons also takes place, that already we know. Now here we know that some of the atoms have the nucleus around it, negative charges are revolving around it. But here in some cases there are some molecules, that molecules have the negative charge center and the positive charge center, both are supposed to be concentrated. So that we'll see here. Only in some molecules I am telling here, that is not belongs to all molecules. Some molecules may contain the center of positive charge and the center of a negative charge. It may be concentrated at a single point. That atoms, molecules we are discussing now. Positive charge and negative charge, both the center, it will be concentrated at a single point. So if you see here, this molecule contain the positive charge and negative charge, both the centers, it will be concentrated at this single point. This type of molecules we called non-polar molecules. This is a very important question for board exams. Non-polar molecules. What is a non-polar molecule? The molecule whose positive charge center and negative charge center coincide, that molecules are said to be non-polar molecules. Here I will write the definition: non-polar molecules. This definition is very important. Here we will write the molecules whose positive charge center and negative charge center coincide are known as non-polar molecules. Generally, these non-polar molecules will have symmetrical structure. Remember this point, they have symmetrical structure. So non-polar molecules will have symmetrical structure so that the electric dipole moment of such molecules is zero. Here, this is very important point. Non-polar molecules means the center of positive charge and center of negative charge coincide like this. This type of molecules we called non-polar molecules, and non-polar molecules will have symmetrical structure so that the net electric dipole moment of such molecules will be zero. Why? Because when electric dipole moment will be takes place, already we have seen in first chapter. What is electric dipole? Electric dipole means the two equal and opposite charges are separated by small distance. Here, if you see the positive charge and negative charge, both are concentrated at a single point. So there is no separation between them. So what about the net electric dipole moment of these molecules? It is zero. So here, this is in this case, electric field is zero. Electric field of this non-polar molecules is zero. So here we'll write no electric field. Suppose an external field is applied to these molecules, then what happens we'll see. Here we are applying an external electric field. If you apply the external electric field to this type of molecules, what is going to happen? The positive charge will experience the force and also negative charge will experience the force. But in which direction the force will be takes place? The positive charge will experience the force in the direction of electric field. Here, this is the direction of electric field we are applying. This is the external electric field direction. So both are experiencing the force. That's why positive charge and negative charge, both it will get displaced by certain distance. So here this is a positive charge will experience the force and this is a negative charge in this direction. So the molecule will get displaced like this. So similarly we will draw for all molecules. Negative, positive, negative, positive. Negative, positive, negative, positive, negative, positive. So here, by the applied electric field, positive charge will experience the force in the direction of electric field, negative charge will experience the force in the opposite direction of electric field. That's why both negative and positive charge get displaced like this. So this is about non-polar molecules. Then now we'll see polar molecules. And here it may ask in exams what are the differences between non-polar molecules and polar molecules. So first we will read the definition, and here this type of molecules will have symmetrical structure, and whereas in polar molecules they have unsymmetrical structure. And what is the electric dipole moment? It is 0, but that is not 0 in polar molecules. And we'll see one more difference examples for non-polar molecules, that is CO2, H2, O2, etc. These are the examples of non-polar molecules. Now we'll see about polar molecules. Polar molecules means if the centers of positive charge and negative charge of a molecule do not coincide, such molecule is said to be polar molecule. So here they have symmetrical structure, here they have unsymmetrical structure. And here so that they have net dipole moment. Why net dipole moment will be takes place? In previous case we have seen positive charge and negative charge both are coincide. So but here they are not coincide. That's why electric dipole moment will be takes place. Here example for polar molecules, that is H2O. So here we'll see in the presence of electric field how the shape of these polar molecules: negative charge, positive charge, negative charge, positive charge, negative charge, positive charge. So like this the molecules will be takes place. Here there is no external electric field. Here no external electric field. So these are polar molecules. Here if you apply the electric field in this direction, this is applied electric field. If electric field is applied, then similarly what we have discussed in previous case, the negative charge will experience the force in the opposite direction of electric field, positive charge will experience the force in same direction. So similarly here the positive charges will experience in the direction of electric field, negative charge will experience opposite direction of electric field. That's why all these charges will align themselves in a particular order. That we'll see here. These molecules, it will be takes place like this: positive charges in the direction of electric field. So this one becomes same. So they will align themselves in a particular order. And here this is a polar molecule and non